Here's another question which says the curve C1 has an equation y equals x square minus 4x plus 7, and a curve C2 has an equation y square equals 4x plus k, where k is a constant. The tangent to C1 at the point x is equals to 3 is also tangent to C2 at point P. Find the value of k and the coordinates of P. Okay, so there's some line C1 and it has a tangent at some particular point, and that tangent is also tangent to another curve, which is y square equals 4x plus k. Don't know what it looks like. Let's assume it looks like this. Okay, so the tangent is also tangent to C2 at point P. And we have to find the value of k, which is this value, and also the coordinates of P, these coordinates. Okay. So since this started with the tangent at C1, that'll be found from dy by dx. So dy by dx equals 2x minus 4. X is given, x is equals to 3, which gives us a gradient of 2 by substituting x here. And then we get y equals 2x plus c. To find the coordinates of c, we have to substitute 3 comma the value of y. What's y when x is 3? Okay, so that would be y comes out to be 4. Okay, so at 3 comma 4 we have to find the value of c. Y equals, or 4 equals 2 times 3 plus c, which gives us y equals 2x minus 2. This is going to be the equation of this curve. Okay. Now, this curve is also tangent to the curve. This line is tangent to the curve C2. So 2x minus 2 is tangent to this curve y square equals 4x plus k. That means if we merge these, get a quadratic equation, that quadratic equation will only have one solution because the line is tangent to the curve. Remember the case b square minus 4ac is equals to 0 from quadratics when a curve and a line, they're tangent and they only meet at one point. Okay. Something like this. Okay, so we're going to merge this into a single equation. Expand, rearrange 4x square minus 8x plus 4 equals 4x plus k. Move everything to the same side. We get minus 12x plus 4 minus k is equals to 0. B square minus 4ac equals 0. Solve this. 144 equals, I'm sending the rest to the other side, 16 times 4 minus k is equals to 0. Dividing 144 and 16. And then we get 9 is equals to 4 minus k, which gives us k is equals to minus 5. So k is coming out to be minus 5. Now we need the point of intersection of, in fact, we need the coordinates of P. And what's P? P is where the tangent y is equals to 2x minus 2 and this curve C2 intersect. Now we also have the value of k, so let me clear this and write minus 5 over here. That means we solve these two simultaneously again, but we've already done most of the work till here. So we're going to use this instead. 4x squared minus 12x plus 4 minus k would be 4 minus minus 5, which is a 9, equals to 0. We solve this using either middle term breaking or quadratic formula. So what would be the factors here? Let me just try to figure that out. Minus 6 minus 6. Okay, so the factors would be 4x squared minus 6x minus 6x plus 9. I did middle term breaking. So 2x is common, x minus 3, and then negative, sorry, 2x minus 3, and then negative 2 is common. In fact, negative 3 is common, and we get 2x minus 3. So in both the brackets, we're getting 2x minus 3. So repeated root, which makes sense since it's a case of tangent. So x is coming out to be 3 over 2 in both the cases. Now find the value of y to get the full coordinate of P. So y is equals to, you may substitute x in either one of these equations. I'm choosing the linear one because it's simpler. So that gives me 2 times 3 over 2. 2 gets cancelled. So 3 minus 2, 1. So the coordinates of P are 3 by 2 comma 1. Okay, in the marking scheme, they've also mentioned another set of solution for P and also for K. Please know that it's optional, and in the marking scheme, they give full marks for this solution. And if somebody has also solved it using another method, which actually gives two answers, then the marking scheme is saying that if in case anybody has written extra correct solution, consider that correct as well. So this to begin with gives you full marks even if you don't use the other method to get another set of solution for this equation.